Okay, so today what we're going to do is we're going to begin our look at another way of showing probability or drawing sample spaces. And this is something called using what's called a probability tree. Most of you have probably seen a probability tree, but if you haven't, don't worry. The ones that they're going to give you are the simplest ones we can possibly do. And since you've seen what a sample space looks like, and you know how to compute probability, right? The number of successful outcomes over the total number of outcomes, you'll be able to see the probability tree and understand it fairly well. There are a few things that I'm going to point out to you that they don't really stress, but what else is new, right? I'm doing that for everything. Okay, so we ready? Everybody got your notes titled? Probability trees. My handwriting is getting terrible. Okay. All right, so a tree diagram or a probability tree is a tree or a way of displaying every possible outcomes. So a tree diagram or probability tree, you need to know that means the same thing, is a way to display all the possible outcomes and probabilities for a particular situation. So that's the definition that I want you to have in your notes. Okay? You don't have to write down everything that's from Education Perfect. I'll always underline it or write it down. Okay? So some probability problems are easier to solve using tree diagrams. What it does is it organizes your work. Okay? All right? So a tree diagram or a probability tree, simply a way of displaying the possible outcomes. And one of the strengths of this is that it makes it very easy to read when you have combinations of probabilities, lots of probabilities put together. Okay? All right. So what we're going to do is we're going to look at the basic structure of tree diagrams. These are pretty basic. There aren't too many of these. So if you have some difficulty working these, work some more, right? Education Perfect will let you go back and do the same type of problem over and over again if you need to, okay? All right. So here we go. We're going to do an example. This example, a coin and a die are thrown at the same time. We want to list all the possible outcomes in a tree diagram. So in other words, it's just another way of writing that sample space. But what we're going to do is we're going to show it using all the possible probabilities. Yes?
Are we going to actually write this out in our examples?
Yes, you're going to draw one in your examples. So you're going to have the notes for how to do it on one side, and then you're going to draw it. So that's a perfect time for us to think about some steps. The first step that they don't do, but I think is incredibly important, is you need to write the word start. You need to have a beginning for your diagram instead of just branches start from nowhere. Okay? And usually when you start, 99% of the time, and 100% of the time in this course, but remember, probability, when are you going to have probability in your math courses? From now until when? Year 13. All the way. So you're going to see probability trees from now on, so it's good to start with a good foundation. So usually, your start is what happens before any events. You haven't rolled the die, you haven't tossed the coin, you haven't done anything. Usually. Now, does that mean never? Absolutely not, right? Now, for this course, we're always going to start off fresh for doing nothing. Okay? All right. Second step. Okay? What we're doing here is we're going to use the probabilities for the likelihood or the outcomes from each event. So simply take one event. to be first. Okay? So in this particular example, I'm flipping a coin and I'm rolling a die. It doesn't matter which one of those you choose to be first, but it makes your life a little easier, just a little easier, not significantly easier, but a little easier if you choose the event. Let's make that a definite one, so that looks like lovent. Okay? So if you choose the event that has the fewest number of possible outcomes. So in this particular case, if I'm flipping a coin or rolling a die, which one has the fewest possible outcomes? Flipping a coin, right? It only has how many?
Two.
Which means you're going to have 2 branches. Okay? So, step 3. The number of possible outcomes is the number of branches needed. So in this case, if I'm going to be flipping a coin, then I'm going to need how many branches? How many outcomes? 2 outcomes, so that means 2 branches. Okay. If I'm rolling a die, how many outcomes are there possible? 6. So how many branches? 6 branches. Okay?
I have
Yes.
a question, but on a tree, don't you have to draw 6 at the bottom anyways?
You're eventually going to have to draw the 6 too, but it doesn't matter where they are. And that tree they had was going up. We're never going up. We're always going to be going sideways.
What? I go
Yeah.
down.
You like up? All right.
No, I go down.
Oh, you go down?
Yeah.
Yeah, fine with me. The direction of it is your choice. I always do them sideways simply because, well, you'll see why. All right? I just think it looks better, but you do whatever you want to do as long as you can get them right. I'm happy with it. You know me. I'm totally flexible as long as you do it my way. I mean, no, that's not what I mean. Totally flexible as long as you have a tree that I could read easily and more importantly, that you can read easily. Okay? All right. Step 4. Okay. Now, here, this one is about organization. And they will show this, and it's very important. You need to title the experiment. And you'll see what I mean by that. Okay? That's one thing. And list the event. Remember, an event means that's what you got. So flipping a coin, it lands on heads. Heads is the event. Remember that? The terminology is a little funny for probability. So heads is the event. Okay? And you need to do this for each branch. Okay? So you're going to do that for each branch. So every branch is going to have a title that tells me what you did. Flip a coin. And at the end of each branch is going to be the event, or the thing that you got. So what can you get when you flip a coin? Heads or a tails. So one branch will be labeled tails or heads, and the other one will be labeled tails or heads, right? Doesn't matter. The order doesn't make the slightest bit of difference. Okay? Then you'll simply continue the branching until you have every possibility. Now think about branching. That means it's going to be branch off from something that's happened before, right? A branch, if you have a branch coming off the tree, then there'll be other branches that come off of that branch, right? So don't go back to the beginning. You're going to continue branching out until you have a branch that shows every experiment that you need. Okay. Many times it's easier to go ahead and list the things that are going to happen. But when you do that, you run the risk of running out of room. Because you're going to see these things get big and ugly fast. Especially when you have something like rolling a die, there are 6 different outcomes. So tree diagrams get more difficult to draw if there are lots and lots of different outcomes. So they're better when there are fewer outcomes. Okay? All right. In this course, I don't think you're going to have to decide. I still haven't looked at your exam yet, but I will. In this course, I don't think you have to decide when to use a tree diagram. I think the directions will just simply say, use a tree diagram. Okay? And certainly in your homework right now, that's all you need to worry about, is it will say, draw a tree diagram or a probability tree. Okay? All right, how does that look? The directions look pretty clear. You haven't, I'm trying to use the correct terminology, right? Event, outcomes. Okay. All right, so let's just look at now their experiment. It's flipping a coin, rolling a die. So flipping a coin has 2 outcomes. Therefore, it needs how many branches? 2. Every outcome gets a branch, doesn't it? Okay. With sample space of heads and tails. So those are your two events, the 2 things that can happen. Rolling a die has 6 outcomes, therefore it needs how many branches? 6. But it's going to branch, the 6 branches are going to branch from heads, and the same 6 branches are also going to branch from what? Tails. Each one of the branches is going to branch again the same number of times if the outcomes stay the same. Okay? And you know the sample space for dice, you can get a 1, 2, 3, 4, 5, or 6. Okay? So let's look at their tree diagram that they've drawn so that you can see.
Cool.
It looks very much like mine, except that for a few things that I want you to think about when you do yours. First of all, I like a starting point. Now let me tell you why. Every one of them starts the same pretty much, but if you have to write the word start, then in your head it tells you, I need to know something about the start. Because what did I just tell you? Does it always start from nothing? Mm-mm. What if it says, you already have drawn a red ball? Then are you starting with nothing? Nope. You're starting with something, aren't you? So you've got to be careful. Now, we're not going to do it right. So you're not going to do it right now at this level, but at this level you're going to get in the good habit of writing the word what? Start. Now, if I'd already drawn a red ball, what I would write there instead is red ball. Or something, right? It won't be just start, because start indicates you have nothing, but if you already have something, then that's what you'd write, because that's where you began. All right? And all it does is really make it focus your efforts. Okay? So they started with the coin first, which is perfectly fine. My only thing that I might tell you is that I think you should write down what the experiment is at the top. We flip a coin. Now, on this one, it says heads and tails. Can it be any more obvious that means you flipped a coin? Probably not. Here, at the other one, I would label this die. Because could there be other experiments you could perform where the experiment was 1 through 6?
That's a good thing.
Okay. Yeah. Roll a die. Okay, let's put roll. That does look bad, doesn't it? Roll a die. Die, yeah. Okay. Some of the things that y'all think of that would never cross my mind. Okay. All right? So here we go. So you see that titling it lets you know exactly what you're doing. And because sometimes it's not obvious. Now you got a 1 through 6, so probably you can figure out that that's a rolling a die. But is that the only thing? Could you have 6 people in a race? Yeah. Could you have 6 of lots of different things, yeah? So title them. So and not only does it make it clear what you're reading, but it also makes it clear how many branches you need, and it makes it a lot, and I'll make sure a lot easier if you label them. Okay? So that's what I mean by putting in a title. Now, at the end, this little section they've drawn here, this thing is the sample space. And it should look familiar to you. It looks just like the sample space when we said heads and a 1, heads and a 2, heads and a 3, right? We drew this sample space before together in class. But where they're getting this sample space is they're just reading the branches. So let me change colors here, okay? So let's say we start here, start here, and I go to heads, and then I follow the branch there. That's heads and a 1. If I start at heads and then follow this branch, that's a heads and a 2. And heads and a 3, 4, blah, blah, blah. So what if I do this branch? Tails and a 3. And that's all you have to do. And then what you have is you have the entire sample space. Now, they may ask you to list the sample space, but do I have to make that list to be able to follow a branch? No, right? But it's nice and easy. It's all done there for you if you do. So, look at the problem. Some of the problems they may ask you to follow the branches and then write the sample space, but you technically don't have to. All right? Now I'm going to tell you something else about these. These, they're totally equal, right? You've got 2 branches, then you've got 6 branches. On the top, you've got on the bottom, you got a branch that branches off 6 times as well. They do not have to be the same. Now with heads with a coin and a die, the outcomes are always going to be, the number of outcomes are always going to be the same. But let's say you're running a race or something. There's going to be 3 races, and if you lose 2 of them, you don't get to run another one. So if you have lose, is there going to be a branch after lose? No, you're done. But what if it's lose-win? Will you run the 3rd race? Yep. So it'll have another branch. So you have to be careful about what you're measuring. Again, our trees right now are not going to be that complicated. You're not going to have to worry about those missing elements or those or trees that end or branches that end first. We're going to stick with very simple experiments that you can do. Okay? Now, when you're looking at these trees, these are and situations. You're moving from this, you've got coin and a die, which means that you're simply going to take the probabilities and multiply them together. And we'll talk about that in just a moment, working with them. But I do want you to see one thing. Can you count out for me how many ends there are, how many branches there are there at the end? So let's just do this in another color so you can see exactly what I'm talking about. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many possible outcomes are there for this event? 12. So there's your total number of outcomes. However many branches you have at the end. Now, again, because you're not always going to get the end branches. So if some branches ended earlier, right, you need to count them too as ends. But for us, they all end in the same spot, right? And some number on a die. Okay? So that always tells you how many you're going to have. And then all you need up top is to find the number of successes. Can you all even see that yellow? Never shouldn't use yellow anymore, huh? Yeah, y'all can see it pretty well on the board. Yeah. Okay, so I'll try not to use I thought yellow would show up pretty well. Okay, so the number of successes out of the total number of outcomes, and the total number of outcomes is always going to be the total number of what? Branches at the end. Okay, looks good. Okay, I'm about to remove the writing. Everybody okay with that? You got everything you've want written down? Okay. All right. So find the probability. It's clear to see that there are 12 possible outcomes, right? 12 possible branches. Each outcome has an equal 1/12 chance of occurring, right? Every one of those things, because flipping a coin and rolling a die. So one of these things out of the 12 is going to happen. You're going to get a heads and a 1, heads and a whatever, right? So one of these, like a heads and a 1. Oops, I'm not writing, aren't I? Okay. So you can get a heads and a 1, tails and a 1, tails and a 6, all of those are equally likely to happen, right? And it's simply one thing out of the 12. Do you agree? Okay, so they're all equally likely to happen. All right, then it just goes into your homework. So we're going to do this one together. All right, so this is your example that we're going to draw, the tree diagram we're going to draw. And it actually comes from your homework, so it's, which means that you should do it again because it'll give you a different problem than one, right? If you, every time you go into it, open it, reopen it, it gives you a different problem if you haven't done it. So, all right, so here we go. What we're looking at here is a game involves flipping 3 coins. Complete the tree diagram below, labeling each branch and showing the outcome. Okay? So, we're only flipping coins, but look how much space they give us. Be careful. These things get big fast. I would not have left that much space between heads and tails. I would have made that branch the angle a lot smaller because you're going to see just because flipping a coin only has how many outcomes? But you're going to do it how many times? 3, okay? So, let me start by labeling this, all right? We're going to begin with a start because we didn't have anything to begin with, did we? So we're going to start with a start. What color are you feeling?
Purple.
Color always feeling purple. All right.
I'm wearing a purple shirt too, so.
Hey,
it
yeah,
makes sense.
look at that. Okay, so I'm doing a coin 3 times. So this label is the first coin, right? The first coin I start. Yes, this is your example. I want you to write this one down. Okay? So your first coin. Okay? Now, to be sure that we are all on the same page and working together, and I'm also trying to still remember learn your names. Bua. No, she's not back yet? Okay. Oh, yes? Okay, I'm sorry. Okay. All right. Bua, so from the start, when I flip the first coin, I can get 2 outcomes. What are they? Either a heads or what does the T stand for? Tails, right? So heads or tails. Okay? Sorry. Let me pick on somebody who's more comfortable, but that's okay. So, heads or tails. Everybody agree that's the only 2 possible outcomes? Yeah. Okie doke. Now, okay? So now we're going to branch again. Olivia? Hi, Olivia. Olivia, now, we're going to flip a coin again. So how many outcomes are there for flipping a coin? 2. Good job. Nova? Nova? Okay, Nova. So, but when I flip that second coin, something's already happened. I already have how many branches? Well, look up. 2 branches, right? So I'm going to get 2 more branches off of each one of the ones that I already have. Okay? All right. So I'm going to get, for the second coin, and again, it's good to label these even though they don't. For the second coin, I'm going to get 2 more branches. And I would write smaller than they did. Because you can see how much it's spreading out already. Yeah? Okay? Tessa. Hello, Tessa. Tessa, can you tell me then, from branching out from heads, I've got these 2 branches. What are they going to be? Either a heads or a tails. Okay? Good job. Amy? Amy's not here yet. Yes. Okay. Caitlin. Caitlin? You were so smiling. I didn't know if you were just smiling or not. All right. On the bottom, what can I get?
Bottom.
Uh-huh.
It's what tails.
You betcha. Just because it's the second set of branches doesn't change what you can get. On the second coin, you can flip a heads or a tails, and heads or tails. Okay? All right. Now, Sonari. Sonari. There we go. Now, we're going to flip a third coin. So that means we're going to have more branches. You bet. So let's write it out. Our third coin. And you'll see why you have to write small. Each one of these is going to have a branch coming from it. You see how why you have to write neatly and kind of try to keep them small. Okay, because this is just flipping 3 coins and look how big the tree is getting. Okay, you hate them? Ah.
Look at how tiny it is.
Yeah, in your notes it's pretty hard, yeah. Because I only give you half a page. So I would do, make sure you have plenty of room when you're doing these. All right, and well, actually, you're going to do them here using the lines and such that they give you. Christiana, hello. All right, and now what's going to happen at each one of these branches? I'm going to get heads and tails, and what? You betcha. How far down?
All the way down.
All the way down. Same thing, just repeating over and over again. Right? Because you can either get a heads or you can get a tails. Okay? That's the 3rd time I tossed the coin, so am I done with the tree? Absolutely. Okay? All right. Now, from that, I could list the sample space if you want to. So let's do it. Okay? So what we're going to do is we're simply going to follow each branch, and we're not going to do them all together because we're going to run out of time. But if I start here, I go here, here, and there. So, Julia? Hi, Julia. Julia, if I follow those red lines, I'm going to go from what? Heads to heads. So that's heads, heads, heads. So that's one of my outcomes. Okay? Now, we're going to follow this red line, and I want somebody to tell me what those are. Remy's not here. Christiana, you're back again. Look at that. See, this thing so don't get all comfortable just because you've answered a question, because it can come back to you. So if we're going to follow this trail, what's the trail going?
Tails, heads, tails.
There you go. So that one would be, I just wrote it down. Tails, heads, tails. And the order does matter. Okay? There you go. Okay? So you can just follow along. How many outcomes are possible on this? Anybody? 8. And how can I tell that really quickly? Eight ends, right? So whatever probability you get, it's going to be out of 8. Each one of those is going to be out of 8. So this trail is one of the trails out of the 8 trails that you can take. Right? Looks good? Okay. Everybody got down everything you need to write? I'm going to push the button. Yeah? Okay. All right. Now, we didn't do any probability with those, though, right? So now what we need to do is talk about the calculations with the probability tree. Calculating probability. So once a tree has been set up, stop that. Why are you? Okay, there we go. Once a diagram has been set up, you can add in the probabilities for each event. Now, be careful. Add in means draw it in. That doesn't mean you add, like adding and subtracting. For each event, and use it to find the probabilities for combination of events. An example of a probability tree is shown below. Okay? So this is not the one we've looked at. This is just a made-up one, but you're going to see a couple of things about the tree that we need to know. Okay? All right, so let's write those down. When the probabilities... Oh. Okay, hold on just one second. There we go. So that's got the whole sentence in. Good. So when we're dealing with these, first thing, we can check ourselves a little bit. Okay? All right? The probabilities for each set of branches will always equal 1 if you add them together. Because an event can either happen one way or another way, right? And the event's a certain event is that both, so if you have 2 things that could happen, if you add those 2 things together, then you've got every possibility. And remember, we said that a probability runs from 0 to 1, and 1 means a certain event. So if you have every possible outcome, they have to add to 1. So you see, here is a set of branches, right? And this number and this number have to add to 1. So if you have a set of branches and you put some probability in there and those two numbers don't add to 1, then you've done the math wrong. So go back. They have to add to 1. So each set of branches. So look at this one. See these two branches? That's a set of branches. They go together, right? What's 0.6 and 0.4 make? 1. Add together to make 1. Okay? So you can check yourself. All right? Excellent. Now, get rid of that writing. The second thing, so all you're going to do is follow the correct branches. Okay? So, for example, if I want A, then B, then I have to go to A and then down here to B, right? That's the only way to go from A to B. If a while ago it was the coins, heads, tails, heads, right? You just follow the pathway. Follow the branches. Third, multiply each probability from the branches. Such a teacher, I always go right back to red. Y'all told me purple, I always go right back to red. What is it with teachers in red? All right. So these probabilities are compound probabilities. They're always and statements. So A and B have to happen to make that a success. So they're going to be multiplied together. So you're going to multiply the probabilities. And that tells you the probability for the whole thing. Okay. And just as if you want to check yourself, every ending probability will add to make, what do you think? 1. So if you did the probability for every branch, which is what they did here, 0.42, that, and that. You see here, they took them all together, added them all together, did every single one of them, add them together. It has to be a probability of what?
1.
Because you're going to get some, right? If you get to the end of the branches, that's every possibility, so it's a certain event, therefore it's equal to 1. Okay? Now, the big part for you is this bit right here. That's what you're going to be doing. Okay? Now, this one, they put in the probabilities for you, and they put them in as decimals. But what if you didn't have the probabilities? Well, you're going to have to configure the probabilities for each branch, right? So let's just do the coin one. So what's the probability of getting a heads for one toss? 0.5 or 1/2, whichever you prefer, right? Fraction or decimal. Usually, when you're multiplying together, decimals are probably the best choice, right? Unless if it's a 3, then that means you had to round it. So then fractions are the best choice. Yeah? But you know, in your calculator, you can hit the fraction and then times another fraction times another fraction. You can just use the division symbol if you don't want to change it to fraction mode. So like 1/3 times, and your calculator will store it as long as you keep doing that, right? And so it'll round the answer and not the original. And you can then there's also a button to change your answer from a decimal to a fraction. There should be one key stroke on there. And your calculator is your calculator, so you find out how. Okay? All right. How does that look? Everybody got everything written down there? Okay. So they're not bad. And, of course, most of you have had some experience with them. So Marcus is bored at work and begins throwing paper into a bin several meters away. After lots of practice, he works out that he has an 85% chance of getting the paper in each slot. Use a probability tree to calculate the probability that he will miss 2 shots in a row. So, here we go. Here's our tree. We have our start, which they didn't write, which I like to write. Okay? Okay? And this is the first shot, right? And he can either get it in the basket or what? He can miss it. So it either goes in or out, or missed, right? Those are your two possibilities. So that's why it's two branches. And then he takes his second shot. And so for each one of those, it'll branch again. He either gets it in or he misses. So we want the probability that he misses both times. Well, that means we have to go to miss on the first shot and what? Miss on the second shot. So that's the only one of those that works out of how many total? 4. So what's the probability that he's going to miss? 1 out of 4 times. Okay? All right. Now, but that's if we had an equal probability. But is he going to miss or hit more often, you think? One or the other he's going to do. So, okay, just real quickly here, looking here, so they put in the probabilities using hit and in and miss based on his experimental probability, right? So, when you notice the two numbers have to add up to 1, and then you can just get your probabilities. By taking, in that case, in that scenario, it would be this number times this number, because we wanted miss and miss, and that would give us our probability, which they give you there. Actually, they get all of them. Okay? Who came in late so I can make sure that you're on the roll? Christiana and Sanari. Thank you. Okay? Just so I can make sure you're on the roll. Thank you, ladies. Sorry, I talked the whole period. Oh, well. Not that you're not used to that. Did I call the roll for the rest of you?
Yeah, you did from the beginning.
Okay. Oh, no, I didn't. I did, but I didn't do it right. Okay, thank you, thank you. So who was absent? Does anybody remember? Remy and... oh, she was absent. Isabel was here. Poppy was here. Kara.